Hello. Quick tutorial on the Coriolis effect. But the first thing you have to know is that the world spins. The second thing you have to know is the air around the world, it spins with the world. Yeah, the air moves due to convection, that's true, but it starts off moving with the world. Now, how fast is the world actually spinning? Turns out the world is spinning really, really fast. The Earth's circumference about the equator is about 25,000 miles. And it takes one whole day to turn around one time. And that takes 24 hours. So 24 hours, 25,000 miles an hour, that's very close to 1,000 miles an hour at the equator. Now, how fast is the North Pole going? Well, it takes 24 hours to turn in place. Basically, if you were there in a boat, because it's the Arctic Ocean, you'd just be sitting in the boat, turning around once every 24 hours. You'd effectively have no speed. So we have a change in speed from 1,000 miles an hour all the way down to 0 miles an hour. So what does that mean for Rockville? Well, I did the math, and Rockville is spinning at 806 miles per hour. Soon. It's going pretty fast. 806. Well, you don't feel that, do you? No, because you and your house and your desk and your laptop and all the air is moving with it. So you don't feel it. That's like being on an airplane. If it's a smooth ride, you don't feel that you're moving all that fast because you and your seat and the air is all moving with you. So, but what does that have to do with Coriolis? That has everything to do with Coriolis. Because what happens if you take the air here that's moving at 1,000 miles an hour and you move it somewhere else that's going slower than 1,000 miles an hour? Right, that's where it comes from. Here, watch. So the air here is doing 1,000 miles an hour, all right? Air's there doing 1,000 miles an hour. So what happens if this air mass gets pushed to the north? Well, what happens to it? Well, it's getting pushed to the north, but the Earth up here is going slower than it is down here. And Newton's first law says, well, objects in motion want to stay in motion, right? That's conservation of momentum. So this air mass that's doing 1,000 miles an hour, even though it's being pushed north, it's going faster than the Earth. So if it goes up here to Rockville, it's going to be going faster than Rockville's going. So people on Earth perceive that air as going faster than the Earth, which means it's turning to the right and blowing east. Well, what if an air mass in Rockville is doing 806 miles an hour and it moves south? Well, an 806 mile an hour wind moving south, if it goes down near the equator, where the equator is doing 1,000 miles an hour, this air mass is going slower than the Earth, which means from the perspective of Earth, it's going to be moving the other way. It's like cars passing each other on the highway. They look like they're going backwards, they're not really going backwards. So this wind looks like it's blowing backwards, it's not really going backwards. It's still turning with the Earth, but it's turning at a slower rate. So from people on the Earth's perspective, it's blowing west. It's a little more complicated than the other two, but they do exist. Air masses moving to the east are turning to the right, deflecting south. Air masses moving to the west are turning to the right, deflecting to the north. But if you take a look at all these arrows, what do they all have in common? They're all turning to the right. Every single one of them is turning to the right. If we look at that one, it's turning to the right. If we look at this one, it's turning to the right. If we look at this one, it's turning to the right. If we look at this one, it's turning to the right. All air masses in the northern hemisphere turn to the right. Southern hemisphere, all air masses turn to the left. This is why hurricanes spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Now, how you get this right-hand turn to spin counterclockwise, that's another discussion, but it does work. This is the Coriolis effect. The rotation of the Earth causes air masses to turn in a particular direction. To the right in the northern hemisphere, to the left in the southern hemisphere. See you next time.